Do you see it? First, that I'd like to mention that all of us already have our own understanding. What does it mean, a stent? Nevertheless, the low-profile stents, which were developed pretty recently, it's only a few dozens of years, originally they developed from a stents from the original shape, and the primary goal was to support coils, and stent couldn't do anything else. Of course, there were stents of a large profile, and we didn't have any other tasks, so they made flow diverters even before the branded stents, and only after this we've got braided stents with the profile similar to neuroforms, for example. But gradually they evolved, the profiles evolved, the type of braid evolved, and for the main two types of stenting, and the two that follows, technically pretty easy implemented. And at the next stage, T-stenting, half T-stenting developed, but everything starts with adequate and pretty in-depth studies of the main points. So what is the main difference between the two stents? Look here. Braided low-profile stent look very different. First of all, there is no crowns, no extended markers that hampered worked with classic stenting. Another important point is the particular flexibility, how it is achieved. You can look at any braiding. Typically, it fully repeats the shape, and any modern low-profile braided stents, we don't have that many of them in Russia, but the difference is that they have very active cell, very active flexibility, high level of adaptation to the objects where a stent is implanted. And I'd like to compare it with the assisted stents here, and it can be adapted through compression as to how a cell is cut off. However, the rigidity will not be compared with the type of new stents. Also, stents with new cell, in case of large bifurcation aneurysm, they can be prolapse, reopening of the open cell zone. And in terms of coils, we can say that at some point, a particular part of it can be prolapsed. On the second part of the slide, you see how a laser cut stent began to deform, and at some point it even can be broken. Here's a graph how there is a shift from laser to braided stents. The number goes down very often when you see this, even the braided stent, there is at the moment downward trends. But you know, it's a special case. If we discuss it, we will not have enough time. More and more papers are published, different teams, different groups, they develop their own understanding, and somebody are in favor of braided stents, somebody are into laser cut, others like U-stent, T-stents. But let's look at the old laser cut stents. An attempt of Y stenting inevitably leads to fracture of a stent that had passed through the body of an early implanted object. And here, when we have an open cell, there can be some easiness in implanting. On the other hand, this less hemodynamically stable structure it is totally sufficient to support coils. On the other hand, to totally reconstruct a lost artery may not be enough in this salon. This is a typical example of working with a laser cut stent. It's enough to have acute angle. And look, in this angle, two enterprises are broken. It is senseless to expect that they will be open. It is pointless to rely on further opening with balloons, because initially it is a tube, and the tube will follow certain given regularity. What's the difference between a laser cut with an open cell and a braided stent, where a so-called textile structure of the stent body enables us to cope with such angles? Here, laser cut stent, perfectly implanted, everything is easy, which means every stent has its own safety profile and capabilities profile, and it can meet any concept. So all these names, parallel, T, half T, E-stenting, everything is reduced to what profile of stent is the safest. Aneurysms, the total destructions of A1, A2 angles, or the entire PCR. And here, if the recurrent artery doesn't give away from the aneurysms, we have an endovascular trapping in a parallel form. In the center, we put the necessary amount of coils, and stents open nicely. There is no need to demand just braided stents or open or closed cells. Practically any stent will work. And here is the profile safety for our procedures. We can use smaller diameter stents. We can use stent catheter, microcatheter, and implant the necessary stents. Another situation, again, we talk about the PCA zone, traditionally open surgery. At the same time, if we talk about endovascular technology, it requires its own progression, development. We cannot say that everything is given to clipping. Braided stents work perfectly when an additional branch is developing, and what common laser cut or primary generation stent cannot do. So this is an additional lobbing to the neck, completely replace the white stenting. What are the advantages here? There were a lot of discussions whether white stenting is necessary, where everything can be clipped. Why should we have too much metals? And here we say that one stent might be enough. But a laser cut stent cannot achieve such effect. So we have such an aneurysm, and we only have laser cut stents. There is no point to go for such procedures. So it is important to understand the capability of our stents, and based on it, we should build up every procedure. Here it's an interesting and complicated situation. Somebody said, okay, clipping, or endovasculars would say, let's go for Y stenting. But if we talk about the adequate use of the maximum capabilities of the low-profile stenting, for example, here, what we have, such a broad platform can be formed at the neck level, which can be compared with Barrel laser cut assisting stent from Medtronic, which wasn't very successful because of low elasticity. And the braided stents, very active cell, very active displacement, will develop an additional reopening of the stent body. So we get a sustainable structure which help us to preserve the opposite osteum without overburdening burdening the second ostium with metal. In follow-up, the results are pretty stable at a rather high level, because we say that low-profile braided stents generate an additional flow divert effect. Of course, we cannot rely on it as a flow diverter, but there is an additional flow diversion effect. So without right stenting, we have absolutely good, stable results in 18 months. Look at why stenting with braided stents. Again, the profile is different for Junior, Baby, Elvis, Eva, that will be available very soon. The behavior will be different for all of them because the braid is different, has its own specific for each stance. And depending on the type of braiding, we can get different forms of support. Again, combination of stents is possible. Here we combine a braided and a laser cut with an open cell. And you remember how easily we can pass through the opening additional cell or factors and neuroform. Full arterial reconstruction is achievable, closed aneurysm and reconstruction. That's how it looks schematically. Here is a low-profile stent with closed cell. Look how bifurcation has changed. In principle, it's all the same. Two low-profile stents. We wanted to reconstruct bifurcations. However, the tube wants to reach its initial given form. And we can say it's wonderful. We change the flow, we change the hemodynamics. So in some instances, yes. But if, like here, there was clipping and M1, both M2 osteus are deformed completely, and of course after hemorrhaging and clipping, there are enough changes. The segment mobility has changed, so laser cut stents would not be pretty suitable here. In this case, let's use two braided stents with good cell elasticity. We develop adequate Y stenting, which in this case will play the role of a full reconstruction. That's the primary picture, and that's what we have. A segment is reconstructed, the first stent is reopened. That is why we have re-extension at the bifurcation level, but frankly speaking, we've got braided implant. A very closed picture. We have analyzed around 100 aneurysms for the past 5 years. They have either braided shape or fully fusiform effect or pretty unfavorable situations. And here we should reach a solution having analyzed all hemodynamics. We can talk about parallel stenting, for example. If we had two Silkwister babies, we can talk about two diverters, which will unlock the entire system. We can talk about X stenting, but we opted for Y stenting, and we combined two types of stents. They're junior. Everyone knows it. It's pretty popular in Russia. So from the opposite A2 in the parent A1, it opens without any issues. Levobabic with the maximum active cell allows the stent to go through and opens fully, and we get a good reconstructions of the entire bifurcations with a flow remodeling and form reconstruction. We have the same picture with bifurcation aneurysm of the main artery, pretty good elasticity from stent to stent, pretty good reconstruction, no issue. Where else can we actively use low-profile assisting stents? In cases when flow diverters cannot be used, either because we do not have them at the moment or because a pretty large catheter is necessary. Here, reviews and large meta-analysis reach the same estimates, and we would like to highlight some cases. We say that these are heavily distal aneurysm, 50 to 50, where the aneurysm will develop, so it's not the best option. putting low-profile stents through catheters well known to all of us, it's a really safe technology because as a result, we can obtain full reconstructions, immediate aneurysm closure. We do not need to wait for 6 months as we do after diverter. And it's also pretty safe for patients. Here, it's even a rare case because passing stents through another stent and then have cross-stenting as a really high thrombogenuity factor. And when the aneurysm base is quite wide, these are the stents that are put in parallel to each other. From the opposite side, it's pretty easy for a stent to open. The low profile fill in with coils, and it's not even the questions of its coil size, it's a question of being soft with the minimum traumatic. Here, the anatomy is not that simple, fenestration, but easily reconstructed. The results are quite good. T-stenting, what's the main difference and why we can also employ T-stenting? The main difference is in this zone. Never mind how the movable is the cell in braided stents, but it's important to make sure that we have full opening in the suggested sizes. And the technology that was suggested is just to connect the end of one stent to the body of another one. So it's full connections, one shorter and one longer stent. The main point here is to calculate the shortening of a stent in implanting, making sure that they wouldn't fall into the aneurysm zone and wouldn't shorten too much into the stent, because in this case, implanted would be totally useless. But with sufficient experience, because it's not an easy procedure, but with sufficient experience of working with braided stents, when you learned how to calculate the stent shortening, then T-stenting is very possible. There are also combinations, situations. What suffices that you have one short stent that you would put in a geometrically unfavorable branch. The other stent can be any laser cut stent, which you just connect. Talking about half T, it's when we have to work a little bit further than the osteo of a compromised artery. And with the edge of a stent, we can reconstruct an artery, which is not very easy in treatment. Here, we can even use the laser cut stent because the 3 markers will minimally compromise the flow, and coils can be implanted pretty nicely. And of course, let me throw you a challenge. The more low-profile flow diverters we have, the higher is the implantation potential. When Silk with the baby appeared, that was a huge leap forward because it true flow diversion and reconstruction of both bifurcation and distal aneurysm became possible. And here we have half-T configurations technique, and additions to destructed segments are possible because the main goal is not just to close the sac, but to ensure the stable reconstructions of a destroyed segment. As for the bifurcation, full flow diverter, this is now the main issue, whether it is efficient, whether it is safe, whether in the future it can replace low-profile coil stents, or we still should work in the same direction discussed by Dimitrios Lopez, various intracircular disruptors. Because at the moment, we cannot visualize defects. We cannot analyze the zone where an aneurysm formed. We cannot get inside every vessel. Perhaps in the future it would be possible, and we can give a clear answer what is better, intracircular, putting some devices into the sac, or reconstructing an unhealthy artery, bifurcation, diverter, reconstruction at the moment require additional analysis. Another point, it's senseless to implant diverters if we don't know which result is achieved in flow modeling. So primary results tell us that it's better to implant the flow diverter stent and bifurcation if bifurcation is questionable. So implant the flow diverter in the dominant stent so that non-dominant would not suffer significantly, or even if it's closed, collaterals would have time to develop. And the question of efficacy. In clear bifurcation, diverter has a lower efficacy, but it's all a question for further discussions. In our work, we found that most of our patients were pretty successful with the Brilinta, more than 50%, and a little bit more than 50% were operated with diverters that was in the department Elvis or Lear Baby. Pretty significant percent, around 20%, were in carotid arteries. Here is the area with many atlases, and Elvis and juniors were also matchable. As for the bifurcation aneurysm, here Leo Baby were mostly used. So in 23% of cases, we avoided Y and T stenting, not because we don't like it or think that it's a wrong technique, but the question is to minimize the burden with metal, and here it was pretty successful. Conclusions. The new stent generations do provide us a more reliable stent opening in practically any vessels. Changing the design of braided stents in the absence of a stent crown enable efficient T-and-a-half stenting. An ability of a stent for additional reopening at the level of aneurysm neck and a branch development enable us to work with a single stent. In Gillian technique, it is expedient not to separate the braided stent before coil embolization is completed. When we remove a catheter through which coil embolization was performed, we finally detach a stent and its body is expanding, and it helps us to avoid diastasis. There is no such issue with laser cut stent because as soon as the space is available for opening, there is a full opening. Flow divert effect is just, to a certain level, because when we increase its density and decrease porosity, the flow divert effect increases, but it's not pretty clear. And the double disaggregant therapy is still necessary. We have minimum experience with the GREL, just a few cases, so further discussions is necessary. The most important is we need the case-by-case analysis of each aneurysm, and the most important is we need to find optimal devices for each particular cases to maximize the effect. Thank you for your attention.